We have drawn the free body of this particular rod now. Now we are ready to apply equilibrium equation. Now what are the unknowns here? This is a known quantity, this is an unknown quantity, this is an unknown quantity. We need to find out x for any theta such that this is an equilibrium, which means x is also an unknown. Okay. Now it is possible to write three equations: the horizontal equilibrium, vertical equilibrium and moment equilibrium, moment about any particular point. Now the choice is an important thing to take a note of. For example, if I take horizontal equilibrium, it will involve the x component of this and RB, both are unknowns here. If I take vertical equilibrium, this will not take part, RA, vertical component of RA and W will take part, and therefore it has unknown RA and X coming into picture. If RA and X come into picture in the vertical equilibrium, can I get one more equation that involve RA and X for equilibrium? That is possible if I take moment about this particular point where I avoid RB and write equation in terms of RA and W. So we will do that exercise. First thing that we do is Fy, so let us say positive direction is 0, is equal to 0. This will give me RA, remember this is theta and therefore RA cos theta is in the vertical direction, is in the positive, minus W equal to 0. So this is one equation that I get. The other equation that we discussed, I am sorry, I made a mistake over here. RA, this is theta, I am right, okay. So RA cos theta minus W equals 0. So this is fine. The other has to do with taking moment about this because we want to avoid calculating RB, which is sigma, let us say anti-clockwise is positive, or I am sorry, moment with respect to B is equal to 0. Okay. What does this yield? About this, I am sorry, about this I have to take moment of this, I have to primarily take this distance, which is this distance. If this is B and this is theta, this will be B by cos theta, and therefore I have RA times B by cos theta as one of them, B by cos theta, and that will give me a moment of this. The other is W, which is acting vertically this way, and therefore this total length, which is X cos theta. So minus W X cos theta is equal to 0. But I already have RA in terms of W from this, which is RA is equal to W by cos theta. If I substitute here, I will get W by cos theta times B by cos theta, or WB by cos theta minus X W times X cos theta is equal to 0. You can see that this term involves W, this term involves W, which cancel off, so that I can get a relationship between X and B, which happens to be X is equal to B by cos cube theta. So for equilibrium to be maintained, this X and these theta should be related in such a way that if I place it at X, the theta should be satisfying this equation.